हेलो फ्रेंड्स, आज हम आपको जो है मेथड ऑफ सेपरेशन ऑफ वेरिएबल के बेसिस पर एप्लीकेशन ऑफ पार्शियल डिफरेंशियल इक्वेशन की चर्चा हम करेंगे इस वीडियो में। एंड इस सेपरेशन ऑफ वेरिएबल के मेथड पर जो आपको एप्लीकेशन है, उस एप्लीकेशन में आपका जो है तीन तरीके के इक्वेशंस हैं जो आपको इसमें सेपरेशन ऑफ वेरिएबल से एप्लीकेशन में सॉल्व करना है। फर्स्ट इज़ द वन डायमेंशनल हीट इक्वेशन, सेकंड इज़ द वेव इक्वेशन एंड थर्ड इज़ अ टू डायमेंशनल हीट इक्वेशन। हम चर्चा यहाँ पर वन डायमेंशनल हीट इक्वेशन के बारे में चर्चा करेंगे, जहाँ पर पार्शियल डिफरेंशियल इक्वेशन जब आपका क्रिएट होगा तो देयर इज़ वन डिपेंडेंट वेरिएबल एंड टू इज़ द इंडिपेंडेंट वेरिएबल। और इस तरीके के कॉम्बिनेशन से बनने वाला जो इक्वेशन होगा आपका जो है एक वेरिएबल के रिस्पेक्ट में फर्स्ट ऑर्डर का डिफरेंशिएशन एंड दूसरे वेरिएबल के रिस्पेक्ट में सेकंड ऑर्डर का डिफरेंशिएशन एंड ऑन द बेसिस ऑफ क्रिएशन ऑफ दैट पार्शियल डिफरेंशियल इक्वेशन इज नोन एज वन डायमेंशनल हीट इक्वेशन। फॉर एग्जांपल, let us consider a one dimensional heat equation and solve it by the method of separation of variable. So let us consider a question is, find the solution of del 2u over del x square is equal to h square del u over del t, for which u0 comma t is equal to ul comma t is equal to 0 and third condition is ux comma 0 is equal to sin pi x by l by method of variable separable या सेपरेशन ऑफ वेरिएबल। दिस इज द मेथड ऑफ वेरिएबल ऑफ सेपरेशन। कैसे हम इसको सॉल्व करेंगे? सो सोल्यूशन इज, सिंस we have del 2u over del x square is equal to h square del 2u over del t, let us consider this be the equation number 1. Now let u is equal to capital X and capital B be the solution of equation 1, where capital X is the function of x only and capital T is the function of t only. This is the method of separation of variable. So differentiating the solution u is equal to xt partially with respect to x, we have del 2u over del x, this be equal to del 2 capital X upon del xt. Again differentiating with respect to x, partially with respect to x, we have del 2u over del x square, this be equal to del 2 of x del x square t. This be the equation number 2. Again differentiating u equal to xt partially with respect to t, we have del u over del t, this be equal to x del t over del t, this be equal to 3. Now using 2 and 3 in equation 1. We have this is the del 2 of x over del x square t, this will be equal to h square del t over del t x. So this can be written as, this implies that del 2 of x del x square, this will be equal to h square del t over t del t. जो जिस तरीके का वेरिएबल था, क्योंकि x इज़ द फंक्शन ऑफ x ओनली एंड y t इज़ द फंक्शन ऑफ t ओनली, तो दोनों ही वेरिएबल्स जो आपके पास हैं वो दोनों ही वेरिएबल्स जो कि अलग अलग हैं, आपका x जो है केवल x का फंक्शन है एंड कैपिटल T इज़ द फंक्शन ऑफ t ओनली, दोनों को हमने सेपरेशन ऑफ वेरिएबल यानी वेरिएबल को सेपरेट कर दिया. नाउ let us we consider this will be k square, this we will let, and this will be the equation number 4. So from 4 we have, there are two cases, one is the for the x and second is the solution for the y. So del 2 of x over x del x square, this will be minus k square, and h square del t over t del t, this will be the minus of k square, like this. So फर्स्ट थिंग्स कि हमने k माइनस के स्क्वायर ही क्यों लिया, तो माइनस के स्क्वायर के बारे में हम आपको बताते हैं कि जनरली देयर इज़ द पॉसिबिलिटी ऑफ के स्क्वायर आर 3. देयर आर 3 पॉसिबल केसेस विल बी एग्जिस्ट इन केस ऑफ के स्क्वायर. फर्स्ट इज के स्क्वायर विल बी नेगेटिव, सेकेंड विल बी के स्क्वायर विल बी पॉजिटिव एंड थर्ड विल बी के इक्वल टू 0. बट it is clear from the equation, this equation is homogeneous type and homogeneous type के solution में trivial solution always होता है. तो solution जब हमारा trivial होगा तो इसका मतलब ये जो solution है ये आपको यहाँ consider नहीं करना है, you have to obtain a non-trivial solution. तो when we take this in the form of k, so when we k square, that is the positive, in that case solution will be exist in the form of exponential term and you have to given the initial condition in the form of sine trigonometric function. So यहाँ से भी आपका solution हमारा exist नहीं करेगा, उस केस में भी हमारा failure हो जाएगा. So we only consider the negative terms and these 3 cases I also will discuss in the next video of separation of variable. But here I focus we only to solve one-dimensional heat equation. So we will let it negative. So when it will be negative, this can be written as del 2 of x over x, this x square, this will be minus of k square x. This implies that auxiliary equation for this equation will be m square plus k square is equal to 0. So m is equal to plus minus ki. So solution capital X is equal to, since particular integral case में pi will be 0 because there is no terms in case of non homogeneous term नहीं है, इसलिए यहाँ पर कोई भी जो है pi नहीं निकलेगा. So x is जो है x is equal to, this can be written as c1 cos of kx plus c2 sine of kx, and from here we can write this with the del t over del t, this will be equal to minus of k square upon h square t, and solving above equation we have capital T is equal to C3, another constant, e to power minus of k square upon h square t. So show so the complete solution of the given one dimensional heat equation is u is equal to, here use the function of x and t, and this can be written as c1 cos of kx plus c2 sin of kx into c3 e to power minus k square upon h square t. This is the solution. This will be the equation number 5. This is the solution of equation 1, that is the one dimensional heat equation. This is the solution. But this solution consists of 3 unknown constants c1, c2 and c3. Now we have to evaluate value of c1, c2, c3 from the given initial condition u0, t, ul, t and ux, 0. So we substitute first initial condition u0, t is equal to 0. Now put in above equation we have. When we substitute, so left hand side it will be 0, c1 cos 0 will be 1, c2 sin 0 will be 0. So we have 0 is equal to c1 into c3 e to power minus k square upon h square into t. So product of these two terms c1 into this is 0. So definitely one term will be 0. Since we substitute the value of x, so this will be not equal to 0. This implies that c1 is 0 because c3 e to power minus k square upon h square t is not equal to 0. So we have to obtain c1 is 0. So equation 5 becomes u of x comma t, this be equal to c2 sin of kx into c3 e to power minus k square upon h square t. This will be the equation number 6. Now we substitute next initial condition. Now put u l comma t is equal to 0 in equation 6. We have u of 0 is equal to c2 sin of kl into c3 e to power minus k square upon h square t. From this equation, if we substitute c2 is 0, so equation 6 will be 0 and equation 6 will be 0, so we have the trivial solution and we have not take this condition. Now c3 e to power minus k square upon h square t is not equal to 0, so there is one possibility sin kl will be 0. This implies that sin of kl is 0, and when this will be 0, sin will be 0 in the case of n pi. This implies that kl is equal to n pi. This implies that k is equal to n pi by l. This will be the equation number 7, and from here we obtain the value of k which we let in equation number 4. Equation number 4. This is the k which is unknown, and now we have to obtain from the given initial condition the value of k also, and that is the n pi by l. So इक्वेशन 6 में जो वैल्यू k है उसकी हम ये वैल्यू सब्स्टिट्यूट कर देंगे. अभी हम इसकी वैल्यू को सब्स्टिट्यूट नहीं कर रहे हैं क्योंकि हमको नेक्स्ट इनिशियल कंडीशन रखने के बाद हम इसको डायरेक्टली सब्स्टिट्यूट करेंगे. तो नाउ वी सब्स्टिट्यूट, now we put last initial condition, that is given u x comma 0 is equal to sine of pi x by l. In equation 6 we have क्या हो जाएगा भैया, ये साइन ऑफ पाई एक्स बाई एल, this will equal to C2 into C3 sine of kx into, when we substitute value of t is 0, then this term will be 1. So C2 C3 sine of kx. Now put value of k from 7 in above equation. We have sine of pi x by l, this will be C2 C3 sine of n pi by l x. Now this equation both sides will be equal. It means by comparison we have C2 C3 is 1 and n is equal to 1. So using value of C2 C3 n and k in equation 6 we have equation 6 आपका ये है, this will be the equation number 6. And when we substitute all these values, this u x comma t, this will be sine of k यानी n pi by l x into c e to power minus of n की value 1, value of n is 1, so pi by l. And when we substitute the value of k, it will be pi square minus of pi square h square l square t. So this is the complete solution. Here no term will be unknown. It is clear? So this will be the complete solution of this equation. Sine pi by l x into e to power minus pi square h square upon l square into t. This is the solution of this one-dimensional heat equation on the given condition this. In this part there is no any term are unknown, and we obtain the solution of one-dimensional heat equation on the given initial condition.